we're going to talk about the Frankenstein algorithm. We've already talked about the Humpty Dumpty algorithm, where you take a string, you break it into pieces, and you put them back together in a different order. That solves certain kinds of problems, right? Where you want to rearrange a string. The Frankenstein algorithm also deals with strings, but it solves different kinds of problems. And we're going to talk about what those kinds of problems are and how we use the Frankenstein algorithm to solve it. But first, let's talk about what the heck Frankenstein is. So Frankenstein is a doctor, a genius, and he created a monster who is called Frankenstein's monster. And he built this monster from piecing together the best parts of other people to make like a super dead thing into a super alive thing. That was his deal. So it's Frankenstein's monster. How did he do it? Well, I'm glad you asked. He started with an empty table, nothing on it. And then he went and found a piece of a person. And then he found another piece and he put them together. And then another piece and another piece. And he kept finding pieces and putting them together until finally he had created his monster. And that is exactly how our algorithm is going to work when dealing with strings. And we'll end up, our monster will be our answer to whatever particular problem we're trying to solve. So with strings, the way the Frankenstein algorithm works is you start with nothing. You start with an answer with nothing in it, effectively an empty table. Then you iterate over each character of original. So original in our case is going to be some string. It's your starting point, some data that we're manipulating. We're going to iterate over every character of original. And then for each character, we're going to add it to our answer if it's appropriate. So depending on the question, sometimes we'll add the character, sometimes we won't. It depends on what we're actually trying to solve. So we're building up this answer from nothing into something until there's no more characters to iterate over, and then we're done and we will have an answer. So let's think about this for a second. Translating this idea to code, what is the string version of an empty table? Think about that. And then just yell it out. Yell out, what do you think it is? You are correct. The empty string. The empty string is the string version of an empty table. So if we want to start with nothing, we're not really starting with nothing. We're starting with something. We're starting with a string, but a string with nothing in it, which is going to be the empty string, which you write with just saying double quote, with nothing between it. There's nothing, no characters in that string. So we're going to work through this example here where we have a string original. It's going to start with the string Frankenstein. And of course, that's just for demonstration purposes. When writing Frankenstein code, you won't know what the value of original is. That's the whole point, that you need this code to solve the problem, because it's some arbitrary value. Maybe the user typed in the value for original and we're manipulating whatever they thought of for us to manipulate. And then we make string answer. We start it with the empty string because it's going to start with nothing. And then the next step is to iterate over each character of original. So how do we do that? How do we iterate over each character of original? What tool do we use to accomplish that? And it's not on the next slide. What do I say next? So here's how we're going to do it. I mean, you know the tool. It's the thing we're learning about right now. But how we're going to do this is we're going to actually remove characters from original. Let me get out of the way. From original, one at a time. We're going to remove one character, the first character, over and over and over again, until there's no more characters to remove. Okay? So we do that. We're doing something repeatedly. We do it with a while loop. So while original.length is greater than 0. So what we're saying is we're gonna do this algorithm. We're going to keep doing this while there's characters in original, while there's more than 0 characters in original. Okay? So as long as there's a character, we're going to do something. When we run out of characters, when we run out of characters, we will stop doing anything. And what's the thing we're doing? There's a comment here that's telling us it's the same thing from the algorithm. We're going to remove a character from original. So while there are some characters in original, we're going to remove one of them from the original. Okay, so here's what that code's going to look like. The second line of code is what does the removing. So original is assigned the value of original.substring 1. So that's going to take everything starting at index 1. Remember, we start indexes from 0. So the first character is index 0. the second character is index 1. And by using the substring with one argument, it's going to start from index 1 and go all the way to the end of the string. So original.substring1 is going to return a string that has all of the characters from original except for the first one, starting from the second character all the way to the end. And then we're assigning that value to original. So we're taking original, we're removing the first letter, and then we're changing the value of original to be this new version that doesn't have the first letter. We have removed the first letter. But right before that, we don't want to just remove that first letter. We want to do something with that first letter. So we're going to have to get the first letter before we remove it, store it in a variable. So after it gets removed, we still know what it is. So I've created a variable called string letter, and I'm assigning it something. How do we isolate the first character of original? So think about that. How do we isolate? How do we get the first character from original before we go ahead and remove it from original? What tool are we going to use? Just yell it out, call it out. Yes, you're correct. We're going to use substring to do this, and we're using substring with two arguments, 0, 1. So we're saying from original, I want to take the substring starting at index 0, the first character, up to but not including index 1, which would be the second character. So you get the first character, you stop before the second character. That's just one character, the first one. We store that into the letter variable, and then this next line of code actually removes that first character. So now we have the first letter, and then we have everything except for the first letter. That's so far what we've set up. Now for our algorithm, we're going to add the character, this letter, to our answer if appropriate. So for starters, we're just going to say it's always appropriate. It's always appropriate to add this letter. And how do we add something to a string? We use concatenation. It's just the plus sign. Adding strings, adding numbers, same symbol. So here, what I'm going to do is I have answer, which starts as the empty string. I'm going to change its value. I'm going to assign it a new value. That new value is answer itself plus the letter. So whatever answer was plus a letter is going to get me my new answer. So I've just taken this first letter of the original and added it to the end of my answer. That's it. So here's an example. This is what Frankenstein code looks like. Okay, this is solving some problem. I didn't actually talk about what the problem it's solving is. So let's trace this code and try to figure out what is it doing. So I'm going to bring this over to here, and that's it. It's real little. I hope you can remember what was there, but I'm gonna trace it here. But we're not going to use the string Frankenstein. It's way too long. It will take me way too long to trace that, and I want to respect your time. So we're going to say that original is actually assigned the value. We're just going to say A, B, C, D, just for demonstration purposes. Real easy. Okay. Let me switch to a black color here. So the first thing that happens, original gets its value, A, B, C, D. I'm going to write that. So we're tracing this, right? We trace anything. Whenever there's a variable, you make a column and you write its value in the column. And as that value changes, you cross off those values and you write the new value. So original starts as A, B, C, D. That's that first line of code. The next line, we create the string answer. So I'm creating a new column, answer, and it gets the value of the empty string. So I'm just going to write the double quotes here to represent the empty string, because that's what answer starts as. Now, the while loop is checking if original.length is greater than 0. So I'm just going to put right here between them, I'm going to put the length of original, which is currently 4, right? Because there's four characters, the length is 4. 4 is greater than 0. So the while loop is true. We're going to execute its body. So the first thing it does is it creates the variable letter within the scope of the while loop. Letter is going to get the substring from 0 to 1 of original. So original here, remember my indexes are 0, 1, 2, 3. So the index from 0 to 1 is going to be just the letter A, starting from 0 up to, but not including 1. So letter is A, the first letter from the string. Then the second line inside the while loop is saying original is assigned original.substring 1. So starting from index 1 of original all the way to the end, it's going to be the letters B, C, D. It's everything but the first letter. And then that value, B, C, D, is being assigned back into the original variable. So we cross off original, and now original is B, C, D. We've removed the first letter, and we stored the first letter in the letter variable. The third line of code in the while loop is going to concatenate answer plus letter and assign that value back to answer. So answer is the empty string. The empty string plus A is going to give you A, and that's going to be assigned back into answer. So now answer has the letter A in it. And now we get to the end of the while loop, and what technically happens at this point is we're leaving the scope of the while loop temporarily. So letter actually goes away. Letter gets destroyed at this point. We go back to the top of the while loop and we check the condition again. So we check, is original.length greater than 0? Well, original.length is now 3 because there's 3 characters in original. So yes, 3 is greater than 0. So we run through the 3 lines inside the while loop again. We create letter. I've already got the column for letter right there. But now it gets the value from 0 to 1. But now the value from 0 to 1 is the letter B. Okay, because it's the first letter. 0 to 1 is always going to be the first letter. Then the next line is going to get the value from 1 to the end, which is going to be everything but the first letter, CD. It assigns that back to original. So original is no longer BCD. Now it's just CD. And then the third line is going to take answer and concatenate letter to it. Answer currently is A. A plus letter, which is B, is going to give you a B. Let me cross off answer because that gets assigned back to the answer variable. Okay, scroll it up a little bit. Now we exit. We're at the end of the while loop, so this letter variable goes out of scope. We go back to the while loop header. We check its condition. Is the length of original greater than 0? Currently, the length of original is 2. Yes, 2 is greater than 0. So we run through this code again. The first line of code isolates the first letter of original and stores it in the letter variable, C. The second line of code is going to take everything but the first letter and assign it back into original. So original becomes D. And the third line of code is going to take whatever answer is and add letter to the end of it. So we go from AB to ABC because letter is getting concatenated onto answer. We get to the end of the while loop. Letter goes out of scope. We check the header. Is the length of original greater than 0? Currently, the length of original is 1. Yes, that is greater than 0. So we run through this whole thing again. We get the substring from 0 to 1 of original, which is the letter D. That gets stored into our letter variable. So that's a D right there. Then we get the substring from 1 to the end. This is where it gets, if you overthink this, you might get a little panicky. Oh my God, what's happening? But it's just a tricky thing. This is just the way it works. And it's good for us that this is the way it works. So currently original has 1 character in it and it's at index 0. Okay. When you use the substring, and we were trying to get the substring from index 1, which doesn't exist, to the end, this will work for us. What happens if the argument to substring with 1 argument is 1 too big? So 0 is the last index in our string. 1 is not existing, but it's right after our last one. Totally fine. What we end up getting is exactly what's here, which is nothing. And how do we represent nothing in a string form? It's the empty string. So substring of 1 is going to give us back the empty string. So now original has the empty string in it, which I'm representing by 2 double quotes. The third line of code is going to take a letter and concatenate it to the end of answer. So answer becomes A, B, C, D, which is behind my big head. There we go. And then we're at the end of the while loop. Letter goes out of scope. We go back to the header. We check its condition. Is the length of original greater than 0? Well, the length of the empty string is 0. 0 is not greater than 0. So now the while condition is false. We no longer execute the body. We skip over to the end of the while loop and we run whatever code comes after that. In our example, there is no more code. So we are done. And the value of our answer is ABCD. So what does this code do? This code effectively copied the value of original into answer one character at a time, and you just ended up with the same thing. So it was a lot of code to basically just assign a value from one variable to another. But this is the baseline of what a Frankenstein looks like. If we add an if statement to this, suddenly we can do all sorts of wacky stuff. And even without adding an if statement, let's make one little change. So here's where we just were. Notice this line of code down here, the last line of the while loop. Answer is assigned answer plus letter. All I'm changing here is swapping answer plus letter to letter plus answer. Okay, that's it. So what I want you to do, let me make this big real quick. I want you to pause the video with this up. Not yet. Let me keep talking for a second. You're going to pause the video, and I want you to go through that tracing exercise just like I did. Trace this whole thing out. Don't keep original as Frankenstein. Use A, B, C, D, just like I did. So just those 4 characters. Trace through this code, write out that chart, and see what is the answer. And the only thing that's different is how we're concatenating, right? Before, we were saying answer plus letter. So we took answer and we added letter to the end. If we're saying letter plus answer, then we're adding letter to the beginning, okay? Not the end, we're adding it to the beginning. So go through this step by step. You're only doing this loop 4 times because if you use A, B, C, D, there's only 4 letters. It won't take that long, but go through these motions and see how it evolves and see what you get. What is the value of answer after this code has run? Pause the video and do that yourself, and then come back and I'm not gonna run through the whole thing, but I will show you what the end result is. So pause. No, really, pause. Okay, cool. All right. Hopefully you've done it by now. I know you have. I'm just going to come over here and I'm going to shorthand this whole thing. So if original was A, B, C, D, answer is going to start as the empty string, right? Because that's how we start it. Sorry about my handwriting. You guys are lucky because when I write on the board, it is, if anything, worse than this. Answer starts as the empty string. Then we run through this whole thing. The whole thing is going to, a letter is going to be A. So we say A plus the answer, empty string, we get A. Then the next iteration through, letter will be B. And we'll say letter plus answer, which is going to give us B plus A. Okay. And then the next time through, letter will be C. So, and then we say letter plus answer, we get C, B, A. And then the next time through, letter will be D, and this would be our last time through. Letter plus answer would be D, letter plus answer, C, B, A. And we end up with the value of original backwards. So Frankenstein is the algorithm you would use to reverse the order of a string. And that's like your baseline Frankenstein. And the reason I showed you both of these is because like this does nothing interesting. This does something interesting. This is going to reverse your string. So if you write this whole algorithm out and you're like, oh my God, nothing happened, you probably just did this one line backwards. By reversing that and making sure you add your letter to the beginning of answer, suddenly now your whole string is reversed. Super cool. So now we're gonna make a different change. So here we've swapped our answer assignment back to be answer plus letter. So this is just copying the letter to the end of answer, not the beginning. So we're no longer reversing the string. The string will remain in the same order. What has changed is that we have an if statement, okay? And we're using a little bit of make-believe. So I've written in this if statement, if letter dot is vowel. So we're gonna say is vowel is a method that returns true if the value of letter is a vowel, A, E, I, O, or U. That being said, is vowel is not a real string method. I'm just making that up. I wrote that way over there, right here. Not a real method. I'm just using it for demonstration purposes to save us some space of what actually doing that would look like. You wrote a method already in one of the labs that checks to see if a value is a vowel or not. So you saw kind of that can be a big chunk. It can be a small chunk if you did it creatively. But for demonstration purposes, I'm doing this. I just want to emphasize that if you call is vowel on a string, it will not compile, it will not work. That is not a real method. But if it was, then it would be true if the value of a letter was one letter long and a vowel, which is going to be useful for us here. So again, I want you to pause the video, trace this code, maybe do it with Frankenstein, because you can do it kind of quickly now, because you get the gist of it, and see what do you get if you use Frankenstein and you run through this. What's your final answer going to be? Pause the video, and then afterwards I will do my shorthand and show you what it looks like. So pause. All right, you got your answer. Let's see if I can spell Frankenstein again without a spell checker or something. Let's give me some room here. So if original is Frankenstein, how close did I get? Oh, great. So if that's original, Frankenstein, as this loop goes, we're just going to look one character at a time, right? F, then R, then A, then N. The only time we're adding one of these letters to our answer is if that letter is a vowel, okay? So we can do this pretty quickly. Answer starts with the empty string, nothing in it, okay? We look at the first letter, not a vowel, not a vowel. There's a vowel, A. So we add A. Now our if statement is true. We add A to our answer. So we get empty string plus A gives us A. And then we keep going through these. Not a vowel, not a vowel, yes, a vowel. So we're going to take the E and we're going to add it to the end of our answer. Answer is currently A. If we add an E to the end, we get AE. Not a vowel, not a vowel, not a vowel. I hope I'm getting these right. Yes, a vowel. Now we take the E, we add it to the end of our answer. E. Yes, a vowel. I. Not a vowel. So at the end of this, as we've looped through, we've added to our answer only the vowels, because that's when the if statement was true, and we end up with A, E, E, I is our answer. So this version of the Frankenstein would remove non-vowels, and you could very easily modify it to remove only the vowels if you wanted to. But it's a very basic form of Frankenstein with a condition in there. So loop through the letters and only keep some of them that meet some requirement. I know you're having fun. I'm having great fun. So in summary, this is your Frankenstein algorithm. So you start with an empty answer. You iterate over each character of the original value that you're manipulating. And for each character, you're going to add that character to your answer if applicable. So based on that if statement, what would make it applicable, depending on the type of problem you're trying to solve. There are many problems you can use Frankenstein to solve. I've listed some of them here, the ones that you're going to see most commonly in this class. So reversing a string, we saw how to do that. Counting letters. So of course you could just use dot length to count how many letters are in a string. But what if you only wanted to count particular letters? What if you only wanted to count how many vowels this string has? How many punctuation marks? How many consonants does it have? That's what you can use Frankenstein for. Look at every letter. Is it what you're trying to count? If it is, count it. Finding letters. Does this string contain a particular letter? Of course, you could use index of to solve that, but maybe there's reasons why you want to use Frankenstein to do that, because index of isn't quite robust enough for you. Removing letters. So this is, you can combine Frankenstein with a Humpty Dumpty idea, and basically you keep all the letters except for some that you're trying to remove. We want to remove all of the vowels, which is the same as keeping all the consonants, or you want to remove whatever, capital letters, whatever you're trying to remove. You can use Frankenstein to do that. Sometimes you can use Humpty Dumpty. So that's either one will solve that kind of problem. And comparing consecutive letters, Frankenstein's real good at that, of comparing a letter and the letter that comes after it. And maybe you want to do something. Maybe you want to make sure this is a word that's in alphabetical order. That's, there's weird words. That's like a Will Shortz kind of puzzle master thing to worry about. Or seeing if there's two consecutive letters, like the word book has two O's in it, right, one after the other. Maybe that's something you're interested in for this problem. So Frankenstein's the kind of process you would use to solve that. Yeah, that's the Frankenstein algorithm, and you're gonna in the labs you're gonna be doing like all this stuff using Frankenstein. Cool. Stop in the video. Here I go. Goodbye.